Hi, today I'm gonna start to talk about how to use the OCEANLYZ GUI. If you are familiar with the OCEANLYZ, the OCEANLYZ is the toolbox that we can use it to analyze wave data. It has the two versions. If you go to its documentation website for MATLAB and Python version, both of them are open source, so you can use them with either MATLAB or Python. But there is another version of that. That's the GUI version. Is basically the standalone graphical use with the graphical user interface. So if you don't want it to use it with MATLAB or Python, you can use the standalone version. So the very first time that you open the OCEANLYZ, it's gonna ask you to enter the license formation. After you enter the license formation, this is the page you are gonna get, and it has a very simple workflow in that it has in these tabs here. So you have 5 tabs sitting here. So the first tab is just load the data, the second tab is pre-process the data, then you get to the analyze the data tab, and time series results or the spectrum results. So you can go through them one by one. I will go through them one by one and show you how to load the data, analyze the data. And also these are the toolbar here. With these toolbar, basically you can use it either for export the result that you just analyze, or if you already analyze the data and save them, you can open them, or you can save the data that you analyze them. I'll talk about them later on. So the very first thing that you want to do, you will go to the load data tab, and basically you load the data. The data you're going to load is going to be either the water elevation, water surface elevation, or the water depths in meter, or it's going to be the pressure, the water pressure data in Newton per square meter. Remember, everything is going to be in SI unit, in metric unit. So here, at top of here, it can tell you how we can load the data here, and here it just tells what separate the data. It's going to be the comma separated, space separated, or tab separated, and then if you have the data in order you has a heading, or there's a column that you want to skip to it, you can use these two. Usually for the data, to load the data, you can have the data, each burst of data sit beneath the other set. So basically you have one dimensional data, or you can have each burst of data sits in a separate column. So I will show you just both of them. I have 2 samples data. So the first sample data is like that. So you have the data, all the data is just going to be in the single column. So each burst of data, it just comes after the another. So you have single column data. All the data goes one after another. Another way of that is that you have it like this. So each burst of data, you have it in one column. For example, here I have the column. The second column has the first burst. The third column has the second burst, and so on. And the first column here has the time. So you can use either of these two formats to import the data. So either each burst just sits beneath the previous burst, or each burst is in own column. Also here, for example, you see here we have the heading row, and also we have the column, the time column. So if we go to the OCEANLYZ, we want to skip these two. For example, if I want to upload these data, I can go here and say, hey, the first row to read. If I want to skip the first row, I can say, okay, start to read from the second row. So just skip the first row. Or if I want to skip the first column, so I can go to say, start to read from the second column, skip the first column, and it will do that as well. So depend on which one we want. I have, so it's either this one or this one. I have another videos in the channel, so you can go there and talk about the burst measurement and continuous measurement, and explain there in detail. So here I'm gonna load this data set. It's a single column, so I don't want to skip any row or column. So I leave them 1 and 1, and then I will go ahead and load this here. So say the first column I have, I want to load it, so it's the one I want to load it. So I load the data, and when it loads the data, it tells you how many data points is important. So it's imported, so you can know that. Remember that it's gonna show you the sample data here is not going to show you the entire data set, because usually the entire data set is huge. It's only, for example, here I think it shows the first about 1000 data points here, 999 data points here, and I think here it shows the first 10,000 data points plus the first 10,000 data points, so you can validate the data you imported is correct here. So after you imported the data, you can go to the next step. If your data is clean and doesn't need to be cleaned and everything's okay, you can skip this pre-processed tab. But if you need to do some cleaning, you can use this pre-processed tab. So to show you, let me load another data set that has some bad data in it. So if I open this one, again it says the data point is loaded in 10,024 240, and you can see here I have 3 data that's not good. So 1 NaN data, 1 0 data, and 1 -99 data. This one you will see in some sensors. Usually the sensors, when they cannot read the data, they mark the data with a specific value, for example -99 or -999 or something specific. If I zoom here, because all these 3 sitting here, so if I zoom here, and remember you have this toolbar here, so it lets you to do some work on the graph here. So if I zoom here, so you can see here I have the NaN, so the NaN is missing here. Also I have this point that goes all the way down to 99, and I have this 0 point, and I want to get rid of them. So if I come here, the first part of that, for example, it's gonna, when you have the bad data, it's gonna replace it by interpolating the neighboring data point. It asks you how do you want to do the interpolation. If it's a linear, so it does the linear interpolation. If it's the nearest, it's gonna choose replace the bad data point with the nearest data point. Another point says the change to NaN. If there is any specific data point that you want to be marked as a NaN, you can put it here and mark it as NaN. Here also you can check for that to see if you have any NaN data in your data set. So if I click here, it says yes, we have one NaN data point in the data set. And if I want to replace that, I can just simply click here on replace NaN, and it's gonna, if it can, it's gonna replace that. So let's show that the one they have is at the 5th data point is NaN. So I'll go there and say replace NaN, and we replace, said one NaN data point replaced. And if you look at here, the 5th data point is changed from the original is NaN, is changed to this value here. It's interpolated bit from the neighboring data point. Also here I have this 0 value, and I want to replace that. So it's already 0, but if it was any other value, I can say that say okay, replace that 0 point value, so that one is also replaced. It's not 0 anymore, so in the 10 point. And also I have this point, I want to replace that, so it's going to enter -99, and I will replace that, also that one replaced, so all the bad data point replaced. This part I didn't use it, but this part, if you have the outlier, it tried to move the sliding window to find the outlier using the z-score, and then replace the outlier. So you can define how big you want to be your sliding windows, and then the threshold for the z-score, and then you replace the outlier. Remember, when you're done with all these things, you have to come here and apply changes, otherwise it's still gonna use this original data. So if you just don't want to make any of those changes, reset changes, and it goes back to where it is, and you can just click here and say, okay, apply changes, and then the data set. The data set that's going to be used for analyzing is this data set, not this data set anymore, after you say apply changes. Now let me just load a good data set without any problem. So I will load this data set here. That's a good data set. I know it's good data set. I don't need to do any pre-processing. So I jump to the third tab, which analyzing the data. Here you have to input some parameters basically to tell the OCEANLYZ what you want to do. So there are part of the data that says required properties. So no matter what you are going to do, you are going to enter the data in this top I would say the rectangle here, all the information here. Then you have another one here that's only required if you are doing the spectral analysis. Basically, if you are doing spectral analysis, this is what you are going to use it. This part is the third part. The third window here is only if the data is the pressure data. So basically, if your data is pressure, then you need to fill this part. And these are the optional part that I will talk about. So the required properties, so no matter what you want to do, you have to work with them. The data I have are the water level. You can see this the water level here is changing. So the water level, it's not the pressure. Remember, the water level is in meter, the pressure is in Newton per square meter or Pascal. What I want is the wave or water level or wave plus water level. You can go to help or into OCEANLYZ website for detail of what each of those parameters mean. But basically, when I'm saying wave, means I only want the wave data to I want it to analyze data and get the wave as an output. If you put it on the water level, it means that you have the pressure data, and you know the pressure data. When you measure the data with pressure, you're going to lose some energy because of the location of the pressure sensor. So basically, it account for that pressure loss or energy loss and give you the water level. And again, if you have the pressure data and then you want both the original water level and the wave properties, you can use this. So, and here is that, do you want to do the spectral analysis or do you want to do the zero crossing analysis? So here I want the water level, the input is water level, the output is the wave, the analysis method is spectral. Here the data set I have is the 5 bursts of data, and each burst is 1024 seconds, and it was generated. I generated it at the 2 hertz. This part is that if you're doing the spectral analysis, basically you're going to say what's the range of the spectrum we want to keep. Usually the very low part of the spectrum or very low frequency and high frequency are not good data. They are noise, and you don't want them. So usually for the lower part you go with this range or whatever range for you, and for the higher range you can go up to the half of the sampling frequency. So if it is 2, you can go above 1, but if you don't set it, it automatically set it to half of the sampling frequency. So you can set it, if you don't, it's going to automatically become 1, or if you want to a smaller change, smaller than 1, you can use it there. This part that we use it for pressure data, I'm just explaining it, but we are not going to use them here. Here's that, as I said, the pressure data, when we have the pressure data, we are going to lose some energy in the water column because we put the pressure sensor underneath the water. So some of the wave energy is going to dissipate before it reaches the pressure sensor. So basically, these parts going to account for the energy you lost during that part, and most of the time you want to tell him what range do you want to account, what range do you want to correct the energy loss. Generally, you don't want to go to the very high frequency or low frequency. Usually something like that, or a little bit higher or lower than is okay. And this one is the pressure sensor height from bed at what's the height of the pressure sensor from the water bed. Again, for more detail, you can go to the help or the OCEANLYZ manual and see what each of these parameters does. But usually, except these two, usually the other ones might be you want to let it to calculate it automatically. You don't want to change it to one. You leave it as constant. And these three depend on what the case you have is going to be changed. Water density that you have depend on what type of water you have. For example, if you have the salt water, usually it's 1024, 1025. Is that this is the NFFT is the number of fast Fourier transform data point. So basically, if you use the spectral analysis, the number of data points in the spectrum is going to be half of these plus one. So you can choose how many data points you want here. It just the more data point, the less data point. The only thing is going to give you visually you got more. You got the smoother outcome visually. Otherwise, the result, the value of results is not going to change. Only the shape of the spectrum is going to be more smooth. Get the smoother outcome. Also, if you have the C and SOL energy and you want to separate them, you can come here and set them to separate them or not. Remember, the SOL are the waves that not generated locally. They comes from outside the area that you measure your wave data. And then after you set all the parameters, you can set start analysis. Remember, as I said, the data sets usually are very huge and there has lots of data points, so it's going to take a while. For this one, because it's a very small data set, it only has 5 there. It's going to be done very quickly, but for the larger data set, you might need a couple of minutes or even hours to get it finished. So if I start the analysis, so it's a start analysis and finish it, as I said, it's 5 pairs. And as soon as it's finished, if I go to the time series here, I can plot the time series data. So it shows me, because I choose here the spectral analysis, it shows me the values that can be calculated from the spectral analysis, like zero moment wave height or peak wave period or peak wave frequency. So if I, for example, choose this one and plot it, so it's going to plot that. Or if I choose the period, it's going to plot that as well. If I instead of choosing the spectral analysis, if I assume I choose the zero crossing, it's going to do the calculation and then gives me here it's going to gives me the value corresponding to the spectrum analysis, to the zero crossing analysis, such as the for example significant wave height, for example, and then you can plot. So let's do the spectral analysis again. And if I do the spectral analysis again, here to get the spectrum value of the time series. Also, you can come here and plot the spectrum itself. So if I plot the spectrum, it will plot the spectrum like this. As I said here, if I change this value to the higher value, the one you're going to get here, this shape you're going to get here is going to be a smoother. That's basically the only difference that's going to have. After so either of these, also you can, for example, if you want, plot it here or here. After plotted, you can, for example, save the figure if you want, or you can do some, for example, some customization of the figure, or zoom it, move it, or other kind of thing. After you finish your analyzing your data, you can here export time series, export spectrum, or export water level data in case that you have one, and then it's going to export it as a CSV file. So for example, here if I said I want to do that, so as as a CSV file, I can go ahead and say this line test time series data, and if I save it, it's gonna save it for me. And if I come here, open it, so you can see it says the Bears number and it saves everything here for me. Because I have the zero crossing, it saves these three for me. The same here, you can do this for the spectrum data. You can go ahead and save the spectrum data as a CSV as well. Also, you can save the entire data and analyze data, the data that you inputted, and also all the analyzed data as a Python pickle. For those of you familiar with that kind of data format, that you can open it later in Python or MATLAB or other programming language. So here, if I go there, see it automatically check it as Python. So if I just call it test and save it, it's gonna save it here as a pickle file, and then you can later on open it. Either you can open it here, you can come here and open the data, but remember, if you open it, it's gonna delete whatever you have here, or you can open the other programming language. So here also next to that, each time that you saved, each time that you use this save, it save another file as well. So if I save it as a test, it's going to also save another one, test.config, which basically save all the configuration you use for that specific analysis. So later on, if you need them, if you need those analysis, if you want to go back to see what parameters you use for analysis, you can come here and open that config file. And also, as I said, you can come here, and if you already saved them, you said you're going to lose whatever you have here, you say okay, and then you can open that file for you. So it's going to import that information from me. So if you see, it's already import all the data that I already have it here. But so this is how you can import the export or import the data. Also, there are other videos in the channel if you want to learn a little bit about the basics of the wave analysis or some of the parameters or terms I use here. Please refer to those videos. Thank you.